If you haven't done so yet, please pause the video and try to answer the question on your own before listening on. To begin the question, we're going to set forth a couple of definitions. We're going to let V equal the volume of the fish when its air sacs are collapsed, that is, they are not filled with any air at all. And then VA is going to be the volume of the expanded air sacs once they have been actually filled up with air. Now, these definitions will help us understand the question. Let's go back and reread it. It wants the fraction of the expanded body volume. Now, the expanded body volume would be the volume of the fish with its air sacs unfilled with air, or the air sacs are collapsed, plus the volume of those air sacs once they've been filled up with air. That would be the total expanded body volume of the fish. In the numerator of our fraction, we're going to put the air sacs themselves, the volume of the air sacs themselves, I should say. So that would be the VA. So this is the expression that we have to evaluate. Now, we know in general that the density of an object is equal to its mass divided by the volume. Since our fraction contains volumes, what we really want to do is rearrange this equation and solve for V. So we'll multiply both sides by V, so it cancels out on the right-hand side, and then divide both sides by the density. So we can see that volume is equal to mass over density. So, for example, when the fish has its air sacs collapsed, we can say that its volume is equal to the mass of the fish divided by the density of the fish. But then once the fish fills its air sacs with air, it's going to have the following volume. It would have its original volume plus the additional volume of the air that's filling the air sacs, and that would equal the mass of the fish, which is a constant, divided by the new density. Now the question notes that once the fish expands its air sacs and fills them with air, the density is going to be the same as that of water. So we can actually put the density of water into this equation. Now, the density of the fish with its collapsed air sacs was given as 1.08, so we can fill that in here. And then the density of water is 1 gram per centimeter cubed, so we can fill in 1 here. And of course, since we're dividing by 1, we can actually just get rid of it. Conveniently, we'll be able to manipulate these two equations algebraically in order to set up the fraction that we're looking for. Let's consider the top equation here. And what we want to do is actually multiply both sides of that equation by 1.08. In effect, we're solving for the mass of the fish. We can see that the mass of the fish is equal to 1.08 times V, but we also have mass of the fish right here. So we can substitute 1.08 V into this equation right here. We could then subtract V from both sides of this equation. And when we do that, we can see that V sub A is going to equal 0.08 V. Now we're prepared to plug in to this fraction that we had developed earlier. We'll plug in 0.08 V in for VA in the numerator and also in for VA in the denominator. Then in the denominator we can combine the like terms, and then of course the V's in the numerator and denominator will cancel, so that'll leave us with 0.08 over 1.08, which is roughly 0.074. So that would be the decimal form of the fraction. We could convert that to a percent by multiplying by 100, giving us 7.4%. So either answer would be correct. Thanks for watching. If you liked the video, please click the thumbs up and subscribe so you can stay tuned for other videos. You can send in your own question to the email address on the screen, and I'll do my best to answer it on YouTube.